Okay, so when we were discussing elastic collision in one dimension, we had found that u1 minus u2 was equal to v2 minus v1. So, in other words, if we say, we can say that v2 minus v1 was by u1 minus u2 was equal to unity. If you haven't seen my previous video on this, you may please refer to that video. The link is given in the description below. Okay, so what it simply says that relative velocity of separation after the collision, that is the velocity with which the two bodies move apart after they have collided, is equal to the velocity with which they were coming closer before the collision. Relative velocity of separation and relative velocity of approach were equal to the same. That is for elastic case. However, most of the collisions that we come across are not elastic. They are inelastic. They are not also perfectly inelastic. They are in between, where this doesn't hold. In other words, what happens is that relative velocity of separation is generally less than the relative velocity of approach. Why it is so? Because during the collision, because it is inelastic collision, certain amount of energy is lost, kinetic energy is lost. There are some other forms of energy, and as a result, the velocities after the collision has taken place gets altered or becomes a little smaller compared with this. So, relative velocity of separation becomes lesser compared with relative velocity of approach. So we define a term, coefficient of restitution, as v1 minus v2 modulus of this divided by u1 minus u2. This term is known as coefficient of restitution, and it gives us a measure of ratio, or at which the particles after collision separate compared with the velocity with which they approached. Now, if we take a one-dimensional case, we can also rewrite this as what do you say? Minus v1 minus v2 by u1 minus u2, or equal to v2 minus v1 by u1 minus u2. Why is so? See, because v2, the case as you see, this was u1, this was u2, right? These two were moving, they collided, and after collision what happened? This becomes v1, first one, and second one moves with v2. So u1 minus u2, u1 is approaching u2, so u1 is greater than u2, and so they come closer. Here v2 is greater than v1, and that's why we need to find it as v2 minus v1, or their separate difference, if we have to keep E positive, has to be minus of v1 minus v2. So we can use either of these two equations, right? So if we have this, then for perfectly inelastic collision, case number 1, perfectly inelastic collision, what we must have, v2 and v1 are the same, right? They gel together or coalesce together and form a single body. So v2 minus v1 will be equal to 0. If v2 minus v1 is 0, then we must have E equals to 0. Right? Number 2. Okay, number 2 will come. Number 3. If they are perfectly elastic, then what we must have? We had already discussed in my previous video that v2 minus v1 by u2 minus u1, that is coefficient of restitution, is equal to 1. So if E equals to 1, we have perfectly elastic collision. So if we have 0 less than E and less than 1, in this range, we have general inelastic collisions. Most of the collisions we come under this category. Now there is another special case, and that is E is greater than 1. This is known as superelastic. Superelastic collision. This is studied or topics like explosion, when an object explodes and from stationary the objects in the internal parts fly away at very high speeds, then this case is found. E is greater than 1. This is also we are not going to study, but we need to know about that. Okay, time to solve a couple of problems. First, let us say a ball is dropped from a height h onto the ground. Say there is a ball which is dropped from onto the ground, and this height is say h. Okay. Now it rebounds from the ground a number of times. Of course, it will fall to the ground, it will bounce back, and it will keep on rebounding many times, right, before coming to rest. So what we say is that the coefficient of restitution of the collision, that is when the ball hits the floor, coefficient of restitution is given by E. If the ball rebounds for n times like this, then what will be the height after it has rebounded nth time? So this will be its first. It will keep moving up and down and up and down and up and down, and after nth rebound here, at what height, up to what height it will go. To solve this problem, what we need to notice is that, let's assume that just before it reaches the floor for the first bounce, let's say the velocity is v0. Okay, the floor is stationary, floor is not moving, the ball is moving down with a velocity say v0 just before it hits the ground, and after it hits and rebounds, it rebounds with a velocity say v1. Then clearly, by definition, coefficient of restitution will be equal to v1 by v0. Now when it rebounds with v1, goes up to certain heights and then comes back and it hits again, just before hitting for the second time, for the second rebound, its velocity will still be v1. But after the second rebound, when it moves up, let's say it moves up with velocity v2. So for the second rebound, v2 by v1 will give us the coefficient of restitution. For the third, it will be v3 by v2 and so on, till we go and still, let's say after the nth rebound, the velocity becomes vn, and n minus after n minus 1 it was n minus 1. Okay, so if we multiply all these coefficients of restitutions, how many terms we have, how many rebounds we had? 1, 2, 3, 4, 5, 6, 7, 8 up to n. So n times we have to multiply coefficient of restitution, so it will become e to the power n must be equal to v1 by v0 multiplied by v2 by v1 multiplied by so on and so forth till we get vn by vn minus 1. So v1s will cancel, v2s will cancel, it will go, and vn up to vn it will cancel out, and we will be left with vn by v0. Now let's see. We have e to the power n equals to this. Now what is v0? Our object dropped under gravity from a height h. Just before reaching the ground, its velocity is v0. So v0 will be given by it was not thrown, so 0 V naught square equal to 0 square plus 2gh, or V naught will be equal to square root of 2gh. What is Vn? If the object moves up with a velocity Vn and reaches up to height h, then we must have 0 equal to Vn square minus 2g capital H. It reaches up to height h, so this will give us Vn equal to square root of 2g capital H. If we substitute these two values in the expression for En, what do we get? E to the power n in our equation. Vn is 2gh by square root and 2g small h, right? Squaring both sides and simplifying, we get e to the power twice n equal to capital H by small h, or capital H, the height that is required to be found, is equal to h into e to the power 2n. That is our solution. Let's take another problem. A sphere of mass m moving with a velocity of u hits another stationary sphere of the same mass. Hits another stationary sphere of the same mass. A sphere of mass m moving with a velocity u hits another equal mass at rest. If coefficient of restitution is E given, what is the ratio of velocities of the two spheres after collision? That is, what is V2 by V1? What is the ratio of velocities of the two spheres after collision? Okay. To do this, we first say that coefficient of restitution E will be given by V2 minus V1, right? V2 minus V1 divided by U1 minus U2. However, U1 is U, U2 is 0. So we have V2 minus V1 equals to, or by U, which will give us V2 minus V1 equals to E into U. This is number one. Second, if we consider conservation of momentum, conservation of linear momentum, what we will get? Initial momentum is m u1, that is mu, u2 is 0. Final momentum is m v1 plus m v2. That is to say, v1 plus v2 equals to u. This is equation number 2. Right. So if we add equation 1 and equation 2, what we get? V2s will cancel out, so we will be left with 2v1 equal to u into 1 plus e, or we will be left with v1 equals to u into 1 plus e whole thing divided by 2. Right. Again, if we subtract, if we add, this will be v2, not v1. If we add v2 and v2 will be there, v1 will cancel, so v2 is this. And if we subtract 2 minus 1, this minus this will give us 2v1 equal to u into 1 minus e, or v1 equal to u into 1 minus e by 2. Therefore, v2 minus v1 from these two equations, if we take the ratio, we get 1 plus E by 1 minus E. That is our required solution. Okay. So with this, we come to an end of our discussion of the topic work, energy and power. In the next video, we will be starting up the topic of system of particles, that is residual dynamics, for the next video. Okay.